Okay, we're going to be using this paper here that was written by Elliott Sound Products. In particular, this was written by Rod Elliott, and I'll put a link down below if you want to follow through with this thing. But he gives a great bunch of circuits here that are active filters. All right, so let's see here. Let's go to the first example. Okay, so this is the first example here. The input is here and the output is here. It's very strange. The input, so ignore this over here. The input goes through a 1K resistor and then into the gyrator, and the output comes right out of the bottom end of this 1K resistor. So it's basically, it comes through the 1K and then this thing kind of feeds back up and around, and then it comes out here, right? So there's a phase delay caused by the capacitor. That phase delay gets fed back around and you get a cancellation, and it does some filtering type stuff. And it ends up being equivalent to a 1 Henry inductor. So a 1 Henry inductor is a lot of wire. And this does it very easily with just a 0.1 microfarad capacitor. So they're very, very efficient as far as cost and size and stuff. And we should get something that looks something like this high-pass filter here. This sweeps from 10 to 20K. And we should see this type of curve. So let's try that out. All right, and so the filter input and output that we want to deal with is over here. It's labeled on the PC board. It's labeled figure 3.1 gyrator. So if you get one of these boards, whatever you're doing here, this is figure 3.1. The PC board will say figure 3.1 is the place that you should be looking at. Okay, so what we're going to be doing is we're going to be inputting this signal, which is a swept signal from 10 hertz to 10 kilohertz, and then it repeats. So this is 10 hertz, 10 kilohertz, swept filter, okay? And so we will put our oscilloscope on the output. That was the input. Put our oscilloscope on the output, and we get something that looks like that graph, right? It's a high-pass filter, so the low frequencies are suppressed and the high frequencies are let through. So once again, 10 kilohertz to 10 hertz to 10 kilohertz. So that one works great. All right, so, you know, like I said, the equivalent of a 1 Henry inductor, because these are very, very low frequencies that we're operating at. This bend here is around 400 hertz. All right, so great for audio stuff, which is why this audio company uses them. All right, let's go to the next example. They do a analysis here also, a measurement that shows that the circuit is acting like an inductor. The current is lagging the voltage, which happens in an inductor. Okay, let's see here. Okay, so the next one is figure 4.1, and there's two circuits here, a gyrator notch filter and a gyrator bandpass filter. So one of them should look like a bandpass, and one of them should look like a notch. So let's hook those up next. All right, so the bandpass is over here. So we'll go in and out, and we'll take a look. And yes, indeed, it looks like a bandpass. So there you go. That's looking really, really good. And take a look at the number of components that are used here. It's pretty small, right? We just have two capacitors and a couple, three resistors. So we're looking good there. All of the capacitors are 0.1 microfarads for the most part. Okay, so that was the bandpass. Let's take a look at the notch, which is over here. Move this over. I have a bodge on this board. This is the Rev A board, but like I said, I fixed that on the later revisions. But yeah, there we go. It looks like a notch. So that's working good too. I like these circuits. All right, and so we've reproduced these curves here. Let's see here. The next one is gyrator versus active inductor. So there are some circuits that you'll see labeled as active inductor. And you say, well, what's the difference? One is a gyrator. Isn't a gyrator supposed to turn it into an inductor with an active circuit? So they're basically the same, but you can read this for yourself. But they do give slightly different. They are two different circuits that you'll see in the literature. They are labeled two different things, and you will get two different curves, okay? So the gyrator will give you the curve that we sort of already seen before. It'll be this big high-pass one. But the inductor will start out at some predetermined at minus 20 dB here, and it'll go up. So one should have a big curve, and one should have kind of this truncated curve, all right? So let's go see if we could find those. Those are figure 5 on the PC board. All right, so figure 5 is down here. Okay, let's do the gyrator. No, we'll do the active inductor first here. We've already seen it. We've already seen a gyrator, and I'm going to do something else with this circuit. So we'll put it over here. All right. So, as per the book, it does exactly what a gyrator does, but it has this flat spot on the low side here. So it has starts out, and then it goes up. All right. So what we're going to do on the gyrator side, all right, is let me show you the schematic. All right. So the gyrator. It's a 10K into the circuit and then a 100K that feeds back around. Let's change the 100K resistor and see what happens to the signal, okay? Where's my variable resistor? I need my variable resistor. Okay, I'm going to be using this as my variable resistor. I will put it right here at 100 ohms. And we will start off with what we've already seen. So I'll put this here. Go here to the input and to the output. And there we go. There's with 100 ohms, okay? Now I'm going to change it a bit. I'm going to go to 220 ohms, 560 ohms, that's 15K. That's not doing anything. 1K. Okay, 1K is doing a little bit. Oh, wait a minute. That's 1.5K. 2.2K. That 1.5K is not working on my thing here. 4.7K. All right. 8.2K. And we get down to 10K. It's going to be almost nothing. A little bit of roll off here. So we go back to, so it's kind of the amplitude of this thing, and a little bit of frequency, right? It's moving. So you actually can move these things frequency-wise just by changing one resistor. So that's really nice. You can't do that with an inductor, right? And so you can sort of have a potentiometer that sets the cutoff frequency of this filter, which is super, super nice. Okay, let's go to 56. Here's 56 ohms, 47 ohms. You can see that we can change it quite a bit there. All right, so that was kind of fun. All right, again, I was changing R2, which is the 100 ohms feedback. All right, let's go to our next circuit, which is going to be this one down here, 7.1.1. We're going to have a circuit that's made up of an op amp, And then we're going to have a circuit that's made up of basically an emitter follower. So this is just a unity gain buffer, and we're going to use a emitter follower as a unity gain buffer, okay? Be a little bit aware of this circuit here. It goes the plus voltage. It also has a minus voltage running it. So just like the op amp has plus and minus voltages, this has plus and minus voltages on it. All right, so let's try that. Try those two. All right, let's get this out of the way. And we have transistor gyrator down this way, okay? Okay, all right, so the two circuits are this one here, which is our op amp version, and this is our transistor version. So let's do the op amp version first, okay? So this is our op amp version. Let's see what it's doing. And oh, it's one of those bandpass ones, okay? So let's make him even bigger here. Okay, so we have this nice bandpass filter made up of a gyrator and a couple of capacitors, all right? And then we are going to look at the same equivalent circuit using an emitter follower, which is down this way. And we'll move on to that one. And we'll come back up. And we don't see anything at all. And that's because it's way down here. You can just see a little hump of it. That's because we need to be capacitively coupled out. It's actually way down there. I can change the vertical here, and we can bring it up on screen. So, yeah, there we go. So there is a big DC offset because of the emitter follower. If you were using this in a circuit and just had an AC couple output, just put a 0.1 microfarad capacitor output on this thing, you wouldn't have that DC offset, all right? And we can simulate that here. I can go back to, this is ground now. And if I take the oscilloscope and I say I am AC coupled, and that will add that capacitor. And there we go. All right. So we can see that we can either use a op amp or just a transistor. That's pretty cool, right? So again, we're looking at this circuit here. If you get one of these boards, be aware that the pinout of TO92 packages is not standard. And so this one is laid out for a 2N2222, which is, the tab is emitter-based collector. A 3904 is the other way around, so be aware that there's no standard for these. So if you try to use a 3904, be attentive of where the emitter base and the collector go onto the PC board, because the artwork will mislead you if you're not using a 2222. All right, let's look at the next circuit here. All right, so the next one's a little complicated. It's got some other things going on here, all right? So we basically have a gyrator circuit here, it looks like. And then that's coming into a some type of just buffer here on the output, all right? And so there's two things that we can change on this particular thing. There's a potentiometer down here, and there's a potentiometer here, and then there's a switch, okay? So currently I do not have the switch. Oh, the switch is open right now, which is peaking, okay? And peaking will give us these peaks, right? They'll give us these band pass or these band rejects. If I put it the jumper in here, it goes into a shelving mode, which is this low pass or low reject, and so you can have a big curve or the humpy curve. All right, so let's take a look at those. All right, they are over here. They're calling this a gyrator equalizer. Okay. And, all right, let's see what we got on the scope. And it got really big. There we go. So it's doing a peaking thing right now. All right. So let me get out an adjuster. And I'm going to adjust the 1 meg resistor, which is our VR1. And let's see what it does. Well, it makes it small. And then sort of makes it big. Okay, and I'm going to adjust the other one now. Let's see what he does. And he makes it small. And then he makes it go into a, all right, let's adjust that first one. There we go. All right, I think I want to leave this one here. Let's make this one big. Okay, so what seems to be interesting is to change the VR2, all right? And if you change VR2, you can go from a bandpass filter, and if you turn it, it goes into an all-pass filter, and then it goes into a band reject filter. So just by changing that one resistor, you get different shapes on the curve. And they sort of show that here. You can either get a peak this way or you can get a peak down this way. Let's put that shelving jumper on there, okay, and see if we don't get a low pass filter or a high pass filter. Let's see. Low pass. Okay, so in this particular state, I'm going to adjust that VR, what was it, VR2 again? And we can change it from a low pass filter into a high pass filter. So that's pretty cool that just one knob does all of those things. So the final circuit we'll look at on this board is figure 11-1.1, and it's one of those weird 5 impedance totem poles, kind of. They're calling this a frequency-dependent negative resistance, FDNR circuit, okay? And they have replaced 2 of the resistors with capacitors, the 1 location and the 3 location. They've replaced with capacitors, and it should give you an equivalent of this circuit, which is 2 inductors and 2 capacitors, and give you a low pass filter with a little bit of ringing here and then a very fast fall off. So, okay. So let's take a look, see if we can reproduce this one. All right, it's way down over here. So let's see if we can't get my this one here. And I'll put the scope on the output. All right, and let's go ahead and make this bigger so we can see it. There we go. So it is doing a little wiggle there, and I'm only sweeping to 10 kilohertz, so I think this one is cutting around 20K. So we need to change my sweep of my generator. All right. And so that is over here. Let's zoom in over here. All right, so we'll go to the menu. We can go to sweep menu, start frequency, stop frequency, sweep time, sweep mode. You can sweep linear or log. I think I'm sweeping log now. Yeah, I'm sweeping log. And then we can say the stop frequency, what we want to change. So the stop is 10 kilohertz. So let's do it up to 30 kilohertz. Enter number 30 kilohertz. So now we're sweeping to 30 kilohertz. So let's take a look at the scope now. And there we go. We can see the filter response there. We have quite a good ring, and then a very fast fall at around 20 kilohertz. So yeah, it is doing what it's doing. I'm sure you can change some of those values to modify the amount of ring and all that other stuff. Okay, so this is the filter we were looking at, and we did see more exaggerated dip here. This is in log scale though, and we're looking at linear scale, so they may actually be the same. Can I put my scope in log mode? I don't know if I can. I don't want to waste this video doing that. But yeah, it has a little dip here and then a fall. So we are reproducing this as well. So there you go. A little bit long video, but it shows all of the circuits that are in this particular paper. Link down below. All right, and I'll put a link down below for the board also on the share site on PCBWay. So if you want to try things out for yourself, or just maybe even just use one of the circuits.